This is question 10 from the first of the revision quizzes for stats, and it says a system consists of two subsystems again, A and B, with independent failure times arranged in series. If A has a viable time to failure with shape parameter beta equals 0.5 and characteristic life eta is 9.2, and B has a viable time to failure with shape parameter beta is 0.5 as well, and characteristic life eta B equals 8.6, determine the mean time to failure of the system. So let's have a look at how we do this. Well, there's an easy way and a hard way to do this question. The hard way, which we'll just explain first, is the way that will probably spring to mind mostly, which is to note that if you've got two systems or two subsystems or components in series, then the reliability of the system is going to be equal to RA times RB, and that'll give you your reliability. And then we can say that mean time to failure is the integral from 0 to infinity of RSys, which is going to be RA RB dt. And then you've got viable distributions, so we can look up what the reliability of a viable distribution is. And a viable distribution, so let's take one of these. RA is going to be equal to e to the minus t over eta, all raised to the beta. So you can do that. That would be option A. And I don't think that'll work out too badly, but it looks more complicated than what I'm hoping to do in this video. So the easier way to do it is actually, because we've been given, and it's under this condition only, that beta is 0.5 for both terms. In other words, they're the same shape. There's actually a formula for working out mean time to failure directly, and that is given by equation number 105 in our sheet. 105, and it says that mean time to failure of the system is equal to an ugly looking thing in brackets. So we've got the I equals 1 to 2 of 1 over the etas to the beta, and then all raised to the minus 1 over beta times the gamma function of 1 plus 1 over beta. You'll recall that this gamma function is usually not possible to solve in a straightforward manner unless you're given it, but in this case we're given that beta is equal to 0.5. So in fact I'm going to start replacing a couple of these things. Let's just delete the betas in the interest of saving some space. And so this is 0.5, this is 0.5, and this is 0.5. Yep, got all those right. So what does this become? So firstly, let's just have a look at that. That is the gamma function of 1 plus 2, which is equal to the gamma function of 3. And the gamma function, when it's an integer in here, and this is just worth remembering, when you've got an integer inside the bracket, it's just equal to the integer inside the bracket minus 1, so in this case 2 factorial. And 2 factorial is just 2 times 1 is 2. So this whole thing is just going to be equal to 2. So, and we can just plug the rest of them in. So what do we get? We're going to get, so MTTF is equal to, so we've got our square bracket 1 over eta A, which is 9.2, well, it's a square root really, but 0.5, so raised to the 0.5 is square root, plus square root again, 1 over 8.6, which is eta B to the 0.5, and this whole thing, what's 1 over 0.5 is 2 to the minus 2, and this is all times by 2, because we worked out that this thing just equals 2, because it's the gamma function of 2, 1 plus 1 over 2, gamma function of 3, sorry, which is equal to n factorial, n minus 1 factorial, which is 2 factorial, which is 2. There's the 2 there. So all you have to do is plug that thing into a calculator. So we're going to get square root of, open bracket, 1 divided by 9.2 plus square root, open bracket, 1 divided by 8.6. Raise that whole thing to the minus 2 equals times 2, and that's going to give us 4.45. 4.45. And that's going to be our answer. So this equation here, or we asked for 3 decimal places, no, 2 decimal places, 4.446, but 4.45. This equation here only works if we've got a series set of components or subsystems, and there have to be Weibull distribution, otherwise you don't have your eta and your beta, which I've now replaced with 0.5, and you also must have that beta is consistent across both subcomponents, otherwise you can't use it, and you have to use this other method of finding the overall system reliability and then taking the integral between 0 and infinity. So I hope that helps, and I'll see you in the next one.